Good morning, everyone. Today we're going to talk about my rendering engine and what it can do and how it does it in its current iteration. So first things first, the rendering engine's name is obscure. That's because initially the idea was only to have capabilities for 2D rendering. So it's a 2D render which can be rewritten, and if you squint hard enough, obscure is a synonym for that. Anyways, so here's how you use the engine. You create an application, you pass it to all of the graphics pipelines as template parameters. Then, um, when instantiating your application, it needs a name, a version, and then optionally um, some way to score the devices, the graphics cards in your computer. The default one basically selects for any graphics card that can render to the screen, um, but then it prefers discrete graphics cards over integrated graphics cards. Yeah, and basically higher score is better. So if you want to make your own device scorer, that's important to know. Cool. So then using it, um, this renderer is a thin wrapper around glfw, which basically just handles the creation of the actual window and reading of any inputs like keyboard and mouse events. And if you want to use a controller, then that will also be through glfw. So this is an example application. It's the only example application at the moment. And basically what it does is it does the test triangle, which is basically this triangle. Uh, on the screen, and only this triangle to the screen. It can't do anything else as of yet. Um, anyways, so basically, if you close the window by pressing the X in the corner, then this will return true in the following loop. Also, if you press escape while the app is running, it will exit the loop and close the application. Okay, then the first things first, you get a frame context or a command session. This is, I think, a better colloquial name for it. But anyway, so what it is it is a command pipeline to which you can record various instructions for the GPU. So you get that by calling app.beginFrame. And then on this frame context, you will have all of the methods which is exposed by your pipelines. So in this case, we only have one, draw the test triangle, and you'll notice that this opens in its own scope. So whenever this frame context variable goes out of scope, it submits, well, it ends the recording of the frame buffer. So everything, basically this has to go out of context before you call submit frame. And then you submit the frame to your GPU so it can start actually rendering your scenes and what have you. And then afterwards, you can draw the frame to the screen. So it is important to note that both the begin frame and the draw frame calls are blocking. So this is blocking because it basically it waits for a frame buffer to become available. And this call is blocking because it has to wait for all of the actions that you recorded in your command queue to finish on the GPU side before it can actually draw it to the frame. So there is an opportunity here to do stuff, to maybe save a couple of CPU cycles. That's why these are two different functions. Cool. So now, how does all of this actually work? Well, like I said, the magic basically happens here where you pass the pipeline as one of um, the template parameters to application. So let's go look at how this thing is defined. Okay, so here we are at this triangle definition, and basically a pipeline definition. You can see I also have a concept here to assert that this is indeed a pipeline definition. Basically consists of three stuff: a shader list, an initialize function, and then a draw call structure. This can also be a class, but yes. So just to reiterate, this concept is defined here, and basically you have to have a shader list. It has to have a static function size, which is convertible to a size t, the result of that. And then you have to have a draw call structure or a class, and that has to extend the draw call base class. And then last but not least, it requires an initialize function that returns some kind of pipeline builder. We'll talk about this a little bit later, but basically, yeah, this is just your graphics pipeline info that gets passed here. Cool. So let's go a bit more in depth. So this shader list is basically a set of, I call them shader keys. And how that works is every shader key is basically just a value that you can use in a const expr context. So enum works, or some kind of compile times string or something. But then what makes it special is basically you have to implement it so that it can be passed as a template parameter to a function called getShaderData. And the getShaderData function should return basically anything that's convertible to a stat span of const uint32t. That's what Vulkan requires, basically. Your SPIR-V shader to be compiled to. And so you'll see here I just implemented it by for declaring some functions which are implemented elsewhere. Cool. So this makes it basically what it does is it just removes any duplicates. So if I were to go there, you will see these two are now the same, but then the key set, the result is it only has one. While if I revert it, you'll see that this has two values in this key set. Basically, this can be anything that takes a list of values as parameter, template parameters. But yeah, just use the make set thing because, like I said, it automatically removes any duplicates for you. Cool. Then the initialize function. So for the shaders, I was able to basically use template programming magic to abstract everything away so that you only have to define it like this and everything works, and there's not really any loss of generality that you have to the shader system that Vulkan uses, because basically you define a key, you make sure that you can get that key's data in some way, and that's that. And basically, that's how uh, Vulkan stuff works as well. But then this initialize function is a bit more involved because a lot of the stuff here is where a lot of the customization for your pipeline happens. Um, so this is a bit more involved. Um, that being said, I did try to make some of it more palatable and a bit easier to handle. So I defined this default pipeline builder, and basically is it takes a bunch of stuff as template parameters and then configures your pipeline from what you've defined in this. Okay, so the first thing for this pipeline, there's no vertex inputs. So these are the sizes of these arrays that you have to pass here. But since this vertex does not require any inputs externally, because everything is defined in the shader, um, those are 0. So basically you don't have to pass anything here. Then this is basically your topology types. You can also draw points or lines or polygons or whatever Vulkan allows you to do from here. And this is just, we want to fill our polygons. Basically, it's a solid polygon. We just don't want just the outline or just the vertices. Please fill it with color. And then this is a bit, basically, you have to define the triangles in a clockwise manner. So basically this is center, top, and then right bottom, left bottom. So you'll see that makes like a clockwise movement. So that basically, if your triangle is anti-clockwise, it will assume it's at the back of an object and it will just discard it to save some processing power. And then here, basically, you will see that this and this look almost the same. Basically, this is, you get a list of shaders as part of this parameters, and basically you have to tell Vulkan which shader does which thing. So it is in the exact same order that you passed these things above, these shader keys. So this also have to be in that same order. So vertex and then fragment, and then it does a bunch of stuff, picks default values and sensible options for that. And then the one thing that was not included in this default pipeline builder, but which is still critical, is this pipeline. Basically, you have to create this pipeline layout. So again, there's no layouts. This is again to do with the parameters that we're passing to our vertex shader. But since we're not using instance, we can just use 0 for everything. Anyways, and then you return a result. Okay, so basically this then returns a static pipeline builder. So the reason why you are not just returning a pipeline create info is because the pipeline create info uses a lot of pointers, and those pointers have to be valid. So basically this is a lifetime managing object for any data that you use in your just go here. Yeah, so yeah, basically the idea is I want to get this graphics pipeline create info, but it uses a lot of pointers that has to be valid. So instead, I just want the pipeline builder that will keep that data valid for the duration while I use this. And then the other thing is I have to get this layout from this pipeline builder as well. So basically that's what a pipeline builder is. It's anything that implements these two functions. Um, yeah. So if you want to define your own pipeline builder type, that is uh, very much possible. Um, this is just the one that I do that basically does most of the configuration for me. Um, and everything is on the stack, so there's no vectors or stuff here. It's all arrays. That's why you need to pass in this these sizes in as well. Cool. Then the last thing is this draw construct. Like I said, it has to extend draw base. And basically how this works is any functions you define in here um, will be available in the application context for the frame context. Uh, so basically you get this frame context and then you can call this function. And basically this just tells the GPU how to actually draw whatever it is you want to draw. So as part of the default pipeline builder, I basically declare that the viewport and the scissor is dynamic attributes which I want to set at draw time. So I have to do that now. Sorry. First you have to bind this pipeline, the triangle pipeline, to this command buffer. So for everything, I recommend just basically doing this first, because maybe it's superfluous if you have like two calls that follow on each other, but the effect is basically can then be ignored, but still just basically bind the pipeline to the command buffer, and then you can use the command buffer to do the stuff. So an important thing is while this use a lot of template programming magic to abstract a lot of stuff, there are a lot of places where the abstraction basically is there's no abstraction. So this command buffer returns a vulkan command buffer. So basically this is just a straight up vulkan object. So that means that you can just search how to use this command buffer um, from Vulkan, and the documentation will be valid. Uh, so yeah, so use magic where it makes sense, but then where it doesn't make sense, um, no abstraction. For instance, basically, um, yeah, I can do this VK. So that uses the C++ API, but I can also still use uh, the C API to do the same thing. I think I have to static cats. So I want to do this as a VK view. Go VK viewport pointer, and we're causing it from really. Okay, that's not my fault. That is 100% Vulkan API stuff. That, but anyways, you can just instead of creating a C++ viewport, you can just create a C viewport. Oh no. See, now the C++ one is broken and the C one works. Anyways, so everything is just vanilla Vulkan at this point, um, so that it is easy to get some documentation on what to do here. Okay, anyways, so we set the viewport, we set the scissor, because we set that as dynamic um, data that we need to provide at runtime. And then after that, we draw. We call the draw command. Basically, there's 3 vertices and only 1 instance. And yeah, done. And so basically, what happens is we record the command buffer, and then when this um, goes out of scope, it finalizes the command buffer, and then when you call submit frame, it submits the um, command buffer to the GPU, and then when you call draw frame, it renders whatever the GPU drew to the frame. And that is how everything works. And at the moment, I only have this one pipeline defined, so all my rendering engine can do is draw this exact triangle. Anyways, so in the future, we will be extending this, but first we have to complete the Vulkan tutorial, because I only completed it up to drawing the test triangle. And so I think the next video will probably be on resizing the window. Cool. Thank you very much.